Our planet is a restless soul, always changing. From the moment it formed, Earth has been in a state of perpetual motion, a dynamic entity shaped by powerful forces both seen and unseen. Beneath our feet, the Earth's crust is in constant motion. This outer shell, though seemingly solid and unyielding, is actually a mosaic of moving pieces. We experience this movement as earthquakes and volcanic eruptions. These dramatic events are reminders of the immense energy stored within our planet. But the movement is also subtle and slow. Over time, these gradual shifts can lead to significant changes in the landscape. Over millions of years, continents drift, collide, and reshape the face of our planet. This process, known as continental drift, has been a key driver in the evolution of Earth's surface. Mountains rise and erode, oceans form and disappear. These cycles of creation and destruction are part of the Earth's natural rhythm. The Earth's history is written in the rocks beneath our feet, a testament to the relentless forces that have shaped our world. Each layer of rock tells a story of a different era, a different chapter in the planet's long history. The theory of plate tectonics explains this continuous change. It describes how the Earth's lithosphere is divided into plates that move and interact in complex ways. The Earth's outer layer, the lithosphere, is broken into several large plates. These plates float on the semi-fluid asthenosphere beneath them, driven by forces such as mantle convection, gravity, and Earth's rotation. These plates move and interact with each other, creating the dramatic geological features we see today. Mountains, valleys, and ocean basins are all products of these interactions. The continents we know are like passengers on these moving plates, drifting across the Earth's surface. This movement has been ongoing for billions of years and continues to shape our world. Imagine a world where continents were once joined, forming a giant land mass. This was Pangaea, a supercontinent that existed about 335 million years ago. This was Pangaea, a supercontinent that existed about 335 million years ago. It was a time when all the Earth's land masses were connected, creating a vast expanse of land. This massive continent eventually broke apart, its fragments drifting across the globe to form the continents we recognize today. The breakup of Pangaea set the stage for the modern arrangement of continents. The story of Earth's changing land masses is a fascinating journey through deep time. It reveals the dynamic nature of our planet and the powerful forces that have shaped its surface. It's a story of colossal forces, dramatic transformations, and the enduring power of nature. These forces have not only shaped the physical landscape, but have also influenced the development of life on Earth. This dance of the continents has shaped the evolution of life on Earth. The movement of land masses has created new habitats, driven species to adapt, and influenced the course of evolution. It has influenced climate patterns, ocean currents, and the distribution of plants and animals. The shifting continents have played a crucial role in the Earth's climate system and the distribution of life. Understanding the past movements of continents helps us comprehend the present and predict the future of our planet. By studying these patterns, scientists can make informed predictions about future geological events and their potential impact on life on Earth. About 335 million years ago, the continents as we know them were clustered together in one massive supercontinent called Pangaea. This colossal landmass was a unique feature of Earth's geological history, representing a time when the planet's surface was vastly different from what we see today. This giant landmass stretched from pole to pole, surrounded by a single vast ocean called Pangaea. Pangaea was the world's only ocean at the time, covering nearly 70% of the Earth's surface, and it played a crucial role in the climate and weather patterns of the era. Pangaea was a strange and unfamiliar world. Its vast expanse was home to a variety of ecosystems, but it was unlike any environment we know today. Its interior was likely arid and desert-like, far from the moderating influence of the ocean. The central regions of Pangaea experienced extreme temperatures, with scorching hot days and freezing cold nights, creating a harsh and inhospitable environment. The formation of Pangaea was a slow and drawn-out affair, taking millions of years. This process was driven by the relentless movement of tectonic plates, which are massive slabs of Earth's lithosphere that float on the semi-fluid asthenosphere beneath them. Driven by the movement of tectonic plates, continents that were once separated by vast oceans slowly collided. These collisions were not sudden events but rather occurred over tens of millions of years, gradually pushing landmasses together. These collisions gave rise to towering mountain ranges, some of which still stand today, like the Appalachians in North America and the Atlas Mountains in Africa. These ancient mountains are a testament to the immense geological forces at work during the formation of Pangaea. Pangaea, though massive, was not a permanent fixture. The supercontinent's existence was just one chapter in the ever-changing story of Earth's surface. The same forces that brought it together eventually tore it apart. The tectonic plates that had once collided to form Pangaea began to move apart, driven by the same underlying processes. Around 200 million years ago, cracks began to appear in Pangaea's surface. These cracks signaled the beginning of the end for the supercontinent, as they gradually widened and deepened. These cracks widened into rifts, and molten rock from deep within the Earth welled up, creating new crust. This process, known as rifting, was accompanied by volcanic activity and the formation of new ocean basins. The breakup of Pangaea was a pivotal event in Earth's history. It marked the beginning of a new era, as the continents began to drift apart and move towards their current positions. It led to the formation of the Atlantic Ocean and the separation of the continents, shaping the world we know today. The creation of new ocean basins and the movement of continents had profound effects on global climate, sea levels, and the distribution of life on Earth. This event also had a profound impact on the evolution of life, isolating populations of plants and animals and driving the development of new species. The separation of land masses created isolated environments where species could evolve independently, leading to the incredible diversity of life we see today. The breakup of Pangaea didn't happen all at once. It was a gradual process, with the supercontinent first splitting into two smaller supercontinents, Laurasia in the north and Gondwana in the south. This split, beginning around 200 million years ago, marked a significant change in Earth's geography. Laurasia consisted of what is now North America, Europe, and Asia. Gondwana comprised present-day South America, Africa, Australia, Antarctica, and the Indian subcontinent. The separation of these two landmasses created a new seaway, the Tethys Sea, which would eventually become the Mediterranean Sea. As the continents continued to drift apart, Laurasia and Gondwana themselves began to break up. About 150 million years ago, South America began to separate from Africa, opening up the South Atlantic Ocean. Around the same time, North America started to pull away from Europe, forming the North Atlantic. The breakup of Laurasia and Gondwana had a profound impact on the Earth's climate and environment. New ocean currents formed, influencing global weather patterns. The isolation of continents allowed for the evolution of unique and diverse ecosystems. The world was beginning to resemble the one we know today. Section 4, Zealandia, the Submerged Continent. Hidden beneath the waves of the southwest Pacific Ocean lies a vast submerged landmass known as Zealandia. This drowned continent, about two-thirds the size of Australia, is largely submerged with only its highest peaks, such as New Zealand and New Caledonia, poking above the ocean surface. Zealandia's existence has been debated for decades, but growing geological evidence supports its classification as a continent. It has a distinct geological history with a continental crust that is thicker and less dense than the surrounding oceanic crust. This submerged continent also boasts a wide range of landforms including mountains, plains, and plateaus, all hidden beneath the waves. Zealandia is thought to have separated from Gondwana about 85 million years ago. As it drifted away, it stretched and thinned, eventually sinking below the ocean surface. Despite its submerged state, Zealandia continues to be shaped by tectonic forces, as evidenced by the active volcanoes and frequent earthquakes in the region. The discovery of Zealandia has challenged our understanding of continental formation and breakup. It highlights the dynamic nature of Earth's crust and the possibility of lost continents waiting to be discovered beneath the oceans. Zealandia's unique geology and history continue to intrigue scientists, offering a glimpse into a hidden world beneath the waves. Section 5, Atlantis Fact, Fiction, or Misinterpreted History. The story of Atlantis, a technologically advanced civilization that vanished beneath the waves, has captivated imaginations for centuries. This tale of a lost world has been a source of endless fascination and speculation, drawing in historians, archaeologists, and adventurers alike. First mentioned by the Greek philosopher Plato in his dialogues Timaeus and Critias, Atlantis has been the subject of countless books, films, and legends. Plato's vivid descriptions have painted a picture of a utopian society that thrived before meeting a sudden and tragic end. Plato described Atlantis as an island nation located beyond the Pillars of Hercules, often identified as the Strait of Gibraltar. This location has led many to speculate about the possible real-world counterparts of this mythical land. He claimed it possessed advanced technology, a powerful military, and a wise and just society. The Atlanteans were said to have achieved remarkable feats in engineering and governance, making their sudden disappearance all the more intriguing. According to Plato, Atlantis met its demise around 9,600 BC, sinking beneath the ocean in a single day and night of catastrophic earthquakes and floods. This dramatic end has fueled countless theories and debates over the centuries. Despite its enduring popularity, there is no scientific evidence to support the existence of Atlantis as described by Plato. Modern archaeology and oceanography have yet to uncover any definitive proof of this lost civilization. Many scholars believe his account was allegorical, intended to convey philosophical and political ideas rather than historical facts. Plato's story may have been a cautionary tale about the hubris of nations and the potential for downfall. However, the legend of Atlantis continues to inspire speculation and exploration. Modern explorers and researchers are still drawn to the mystery, hoping to uncover clues that might reveal the truth behind the myth. Some theories suggest that Plato's story might be based on real events, such as the destruction of the Minoan civilization on the island of Crete by a volcanic eruption or a tsunami. These natural disasters could have inspired the tale of a once great civilization brought low by the forces of nature. While the existence of a real Atlantis remains unproven, the legend serves as a reminder of the power of nature and the fragility of human civilization. It challenges us to reflect on our own societies and the potential vulnerabilities we face in the face of natural and man-made catastrophes. In the end, whether Atlantis was fact, fiction, or a misinterpreted history, its story continues to resonate. It speaks to our enduring curiosity and the human desire to understand our past, learn from it, and perhaps avoid repeating its mistakes.